In this video, we're going to introduce a new type of function called a logarithm. Before this, you have to know exponentials because exponentials and logarithms are going to end up being related. Alright, so we talked about exponentials before. They're equations that look like this. So we have our kind of base. The important thing with exponentials is this x is in the exponent, and we have some initial value. And the thing we saw with exponents is they can get us really big numbers really quickly for even just like 2 to the x. If you look at its graph, I'm going to do a really simple approximation of the graph. It has this like low horizontal asymptote, and then it turns and it gets really big really quickly. So even at like 10, I'm getting these really, really big numbers out for exponentials. Alright, but what if we want to convert these big numbers back into small numbers? As humans, once numbers get above like 10,000, our brain can't really like wrap our head around them much more. Like if you think about like $1 million versus $1 billion, both those are just really big numbers, and it's kind of hard to kind of visualize it in our brain. There's actually some good animations online about like the difference between having $1 million and $1 billion and just how different it is. So we need a way to kind of like convert big numbers back into a way that we can represent into smaller numbers. So we're just going to do the reverse of an exponential, and that's the thing we're going to call a logarithm. Alright, so a logarithm, one of the weird things is just the notation for it, but it's the inverse of the exponential. Alright, you have to kind of know that logarithm is just the opposite of an exponential. That's going to make everything else easier for the rest of the unit and the time you're doing logarithms. Alright, but since it's an inverse, it just flips inputs and outputs. So here we have an exponential with base b. We're putting in the value a, and we're getting out the value c. Alright, so that's my exponential, and now we just want to flip it. So the exponential part is going to change to a logarithm, and logs are a little weird because you have to write the word log to say you're doing a logarithm, and just like an exponential, they need a base. So there's different types of logs. Whatever the base of your exponential was is going to be the base of your logarithm. Alright, so that's the first change that's going to happen. The thing I was putting into my exponential a now becomes the output, so that's just because it's an inverse, the input and output switch. And the c, the thing I was getting out of my exponential, is now what I'm putting into my logarithm. Alright, so we can see that if we did have this small exponent that gave us out a big number, now we're going to put that big number in and get out a small value. Alright, so notice, just importantly, again, exponentials have a base. We can have 2 to the x or 3 to the x. So logarithms also have to have that base because each one's going to have its own inverse, log base 2 of x or log base 3 of x. So these things are inverses. Alright, the base is important as well. Alright, so one thing we're going to do in this video is just kind of work on doing that switch between the two, making sure we know where things go to the right place. So log base 2 of 16 equals 4. Alright, when we switch back to an exponential, we have our base of our log becomes the base of the exponential. The thing that's in the log is the output for the exponential. And the thing that was the output becomes the input for the exponential, which is the exponent. Alright, so again, you can just see base is the same. Use the highlighter. Base is the same. Input becomes the output. Output becomes the input. And if you can do that one problem, you can do all the other ones. Log base 3 of 9 equals 2. That means 3 to the second equals 9. Base, input to output, output to input. Alright, base 25. Input is going to become the output. Output becomes the input, the exponential. Alright, so you can do all of these if you just kind of know that, first of all, the base is going to be the same, and then you flip those two places. And now we're just going to do it in reverse. Right, 2 to the 5th equals 32. Again, the base of the exponential becomes the log. Okay, it's a little weird. We have to write out log, just like sine and cosine. You're like writing out what you're doing. But the base is going to be 2. This 5, that's the input for my exponential, becomes the output of my log. 32, which is the output, becomes the input. So again, let's just highlight it since this is the first example on this page. Base of the exponential becomes the base of the log. Input for the exponential becomes the output for the log because they're inverses. And same thing, the output for the exponential becomes the input for the log. Right, so just like we learned with normal inverses, right, just that switch that happens. The only thing here is just like notation for log is a bit different. All right, this one, our base of our exponential is 5. Our output was 125. 1 over 25, and our input was -2, so it switches like that. All right, 10 to the 0 equals 1, log base 10. The 0 was the input here, so it's going to be the output there, and this becomes 1. All right, so just always double check that you're actually switching the inputs and outputs to make sure the expression makes sense. All right, so here's 2 to try on your own. I rewrite these using the opposite function. All right, so I'll show you the answers in 3, 2, 1. Right, so again, bases are the same for each one. Input, output, output, input. Bases are the same. Switch those, and you get the right answers. All right, so for the summary, the most important thing to know whenever you see logarithms is remember they're the inverse of the exponentials. You've been working with exponents and stuff for a long time, so being able to convert things back to exponentials is going to be really helpful when you're working with logarithms because you're not used to working with them yet. And this lesson is just testing you on the fact that you can rewrite these expressions so you know where things go when you're dealing with logarithms.